Thank you for inviting me to talk about trees, possibly the most successful life form on the planet. I've always enjoyed being with trees. I enjoyed climbing the elm trees that lined our park as a child, the discovery of beech and oak woods to walk through, harvesting fruit or nuts from trees, and watching the colours change each year as the seasons pass. In recent years, they've become an important part of the way in which I see the world, which is what I would like to try to share with you today. So, by way of introduction, this is what I hope to cover. There's the general wonderment and sense of celebration that trees give me, and this always gives rise to some big questions, which I probably won't try to answer fully, but which you might like to pursue for yourself. Questions like, how do they grow so big? How do they pump water so high? One thing that I do want to stress from the outset, however, is the time frame that they occupy. They live in a different temporal dimension to us, and their longevity has provided them with a flexibility that we should marvel at. This applies both to individual specimens and to the collective life cycle of different species. Take the silver birch in the picture, one of my favourite pioneer species. They will colonise new ground. When the ice retreats as an ice age draws to a close, or, as in this more mundane circumstance, when old railway sidings in mould are taken for housing and amenity land. It's a short-lived species, about 140 years, but is spread to all continents except Antarctica, and it paves the way for the establishment of many other woodland species. I have a few examples, like this birch, of trees that I like to think of as being hidden in plain sight. We see them in all their diversity all the time, but many of us rarely think about them. I see them at many of the intersections in all our lives, marking time or place, and continuing to satisfy dependencies that we have to meet the conditions we need for living. I will expand on my assertion that trees meet many of the criteria that would be used to assess successful life forms, if such an exercise could be conducted objectively. I then have a couple of slides which suggest how this session might lead to further work within the U3A or further afield. Then there's a short film which illustrates a poem from an anthology by a friend of mine, and there are some concluding remarks at the end of the presentation. I am, of course, happy for questions and comments to be posted. So, here's a tree hidden in plain sight. It's a black poplar which marked a point to cross a small stream in a woodland to the north of Bolton. I used to walk my dog in those woods most days, and this tree became one of the points I would always gravitate towards. They're quite rare now, as they love the damper landscapes, many of which we have drained or transformed. They also helped power and build our industrial revolution. They provided pit props, producing strong, shock-absorbent wood. They were used for many years to provide the springs on carriages, like the hay wain that Constable painted. They're also fire resistant, and many were felled for floorboards and other building frames. Now, the title of this talk is from the book The Hidden Life of Trees, written by a German forester and naturalist, Peter Wolleben. It gives some really powerful insights into how they live their long lives and support themselves and much of the rest of the natural world. The book recognises the fundamental point that trees are not dependent on us for their existence. They have a history that predates us, and they have strategies for survival that will probably see them overcome the inconvenience of having to share space with humans for a few millennia. We are, of course, able to use the presence of trees all around us to imagine and bear witness to the gifts that they offer to the world. As Blake says in this verse, nature is imagination itself. Trees are well practiced in the art of survival, of course, which we can easily see if we care to look. We retain them to complement spaces that we have developed, like this local supermarket site, where there is this island of plane trees outside of the store. Or this ancient Allerton Oak, a Woodland Trust Tree of the Year winner in Calderstones Park. It's about 1,000 years old. It was used, as many ancient trees were, to provide a landmark feature for the conduct of civic affairs. In this case, the meeting of the Allerton 100, when that was the administrative centre for this part of the world. This tree still produces 100,000 acorns in a good year. So just do the sums. Even if we assume that there's only a good year once a decade, when there is a glut of acorns, more than the wildlife can handle, and we also assume that only 1 in 10,000 acorns are able to germinate, this tree will already have produced thousands of progeny in its long life, and is still doing just the same today. This 1500-year-old yew in Gloucestershire has spanned at least 50 consecutive generations of its human neighbours. It's separated from the last ice age by less than 6 lifespans of similar trees. And we can come right up to date. Within the lifetimes of some of our U3A members, when the threats and destruction of the nuclear age have already inspired tree-based memorials whose symbolism includes the longevity available to us through the natural world. This memorial oak is on the south bank of the Dee in Chester and may well be there for centuries to come. I'm now going to turn to a simple proposition that I want to advance. If for any reason some extraterrestrial auditors were to be given a brief to carry out an independent assessment of successful life forms on this small planet, my contention is that trees would have a very good chance of being recognised as the most successful life form. So what sort of things would they be looking at? Well, there would certainly be a measure linked to the ability to survive and thrive. A mature oak, like this one on Offa's Dyke, may have been enjoying life here for 400 years, now reaching well over 20 metres in height. It will produce up to 700,000 leaves each year, generating a leaf area of 700 square metres, which equates to about 3 full-sized tennis courts. Each year, during the 70 days of peak consumption as these leaves mature, it will drink some 60,000 litres of water. It will grow 230 kilograms of wood each year, to add to the 10 tonnes it has built through the absorption and reuse of carbon, all from within its own footprint. Its waste material of 234,000 litres of oxygen is effortlessly released into the atmosphere as a prime source of sustenance for other life forms. Then there's the ability to procreate and support their offspring. By and large, the evidence of the centuries must be that trees do this pretty well by themselves. With a woodland species like this young beech, the process of maturing may be one that takes decades. Many seeds are sown, and they will grow slowly in the early years to ensure that some real core strength is developed. There may well be a lot of competing young saplings with an existing canopy to shade them and help with that process of slowing the growth of young trees. It may be 60 or more years before a naturally occurring gap in the canopy will provide a clear route to the sun for a few of these young trees to put on a real growth spurt and compete directly for the space needed to grow to full maturity. The fact that we may find it difficult to accept a success rate of 1 in a few thousand over a time period that we cannot easily appreciate is not really the beech's problem. Successful life forms may also have the ability to support other members of their own species and to support other species. Trees do this to a remarkable degree. Here we have a chaffinch singing and broadcasting his presence from a prominent perch in a wild apple tree. The ecosystems surrounding our trees provide diversity, beauty and resources which we enjoy and use endlessly, as do other species. Jays, for example, are probably even greater planters of oak in the UK than people, although the drive to supply our heart of oak national need for wood has, for many years, been used to encourage us to help spread the species across our lands. The oaks can live with this. They produce a harvest which will sustain these ecosystems in most years. Then, once every few years, there'll be a glut, ensuring that there are simply too many acorns for all of their guests to use. Some will go to seed. Also in this context of the ability to support themselves and others, we probably need to talk about fungus. And I'd recommend looking up the work of Canadian biologist Suzanne Simard. The YouTube video Trees Talk is a very good starting point. Mycorrhizal fungi exist in nearly all soils. It's the light fibrous material that you'll almost always find when digging around the roots of a tree. They enter into a symbiotic relationship with trees as the mycelium or fungus filaments effectively form a secondary root system. The association between green plant and fungus enables the extraction of nutrients from the tree to the fungus and minerals from soil and rock from the fungus to the tree to take place. This process allows the fungus to grow and spread. In a single mature oak, it may extend a 5-mile root system to a network which would easily go right round the world if it was laid out as a single strand. This is an incredibly dynamic system, constantly developing where it can secure nutrients, anchoring the whole structure of a tree or a woodland or a forest. Critically, it facilitates communication between individual plants, including information on stress and danger, and it physically helps with the transfer of resources between trees and sometimes between species of tree. Now let's just take this ability to communicate and protect each other a little further. Here are a couple of practical examples. The giraffe will come across new growth on acacia or baobab trees and start to feed. Caterpillars in our woodlands will do the same. The trees will need to defend against attack, and it will be stimulated to produce hormones as a result of the wounding they are experiencing, as a response to the saliva of their attackers. Observations on giraffe behaviour show that once they've fed on one tree, they'll move on, but not to the next nearest tree. The wind will have carried the hormones signalling danger to this neighbour, stimulating the production of bitter tannins or poisons to discourage predators. The giraffes will look for their next meal further afield. And similar attacks on a woodland tree in the UK by caterpillars or other insects will produce the same sort of reaction. And so, even where one individual may suffer significant damage, the wind or the root systems will respond. In this setting, the response may be with tannins, or it may be to produce scent, which will attract other birds or insects, which are themselves predators of the attacking bugs. How about the ability to support and enhance their environment? Well, we're clearly realising just how important forest cover now is, with the prominence of political discussions around the Amazon, although many human populations have already destroyed much of their own tree cover, or with the threat to wildlife that our demand for palm oil and other crops creates, actions that may rob future human generations of primate species like the orangutan or mountain gorilla. Against these existential threats to other life on Earth, trees will also adapt to our landscapes and inspire new ways of looking at what we are creating. I agree with Frank Lloyd Wright that the best friend of man on Earth is the tree. I loved the work of Gaudi in Barcelona, epitomised by the architecture of the nearly completed Sagrada Familia, which draws on the natural forms of trees and the light that they will allow to flood into and through a building. Trees also demonstrate the ability to capture and store resources. Within days of the summer solstice passing, they'll recognise the change in daylight hours and start to prepare for the next stage of their annual life cycle. It will take them weeks or months to fruit and drop leaves if they're deciduous, but once the leaves are stripped and the nutrients have been consolidated into the root system or within the cells of the trunk in ways which allow them to act as a sort of antifreeze, they're then able to survive storms and sub-zero temperatures as independent units and, of course, in situ. They provide a backdrop to winter, which is a very different experience to other seasons, but one which is not without its own attractions. As well as storing resources, trees are also able to share resources. This is a photograph taken on the Leighton estate, south of Welshpool. It's billed as the largest group of coast redwoods in the whole of Europe. And although they do not have the same majesty as their North American cousins, they do offer the visitor a sense of strength in numbers, which is what they build on. The value of the whole woodland as an entity can be felt. They've grown with relatively shallow roots for such tall plants, but rely on a degree of cooperation within the group to withstand adverse weather and to maximise the effort that they can devote to fruiting and growth. One of my more recent lines of thought has been to think about whether shielding yourself against external threats on your own is a better strategy than one which is based on cooperation and collaboration with others. Finally, what about the ability to move and to respond to changing living conditions? Well, on the slopes of Mount Etna above Catania in Sicily, it's necessary to cross fairly recent stretches of scarred land that have experienced lava flow just a few years ago. This picture was taken 13 years after an eruption in 2003. Individual trees were clearly lost at that time, but when you're working within very long time frames, the establishment of a new generation of fruiting specimens in little more than a decade is pretty impressive evidence of recolonisation. And there are other well-documented examples of much less traumatic changes triggering the movement of tree lines up or down or along a wide range of geographical features. So all this leads me to a checklist to mark the characteristics that could be seen as indicators of successful life forms. The abilities to survive and thrive, procreate and support their offspring, support other members of their species and other species, support and enhance their environment, communicate, capture and store and share resources, move and respond to changes in their living conditions, and to create art and beauty. My contention is simply that the report back from that extraterrestrial auditor would certainly have to include trees as a successful life form. I'd be interested in seeing whether there were any other serious contenders that could come close to them. Now I just want to mention a few observations that I've made during my lockdown walks in Chester. Observations I've made while thinking about this presentation and the nature of the relationships that exist between humans and trees. The first is the Life for a Life Memorial Forest in the Countess of Chester Country Park, one of some 50 memorial forests around the country. The Life for a Life scheme, it's a registered charity, involves the planting of trees and installing memorial benches to commemorate loved ones. It answers some of the need for actions that people may want to take when they've lost someone. The scheme has been specifically designed to benefit individuals and families who are grieving over the loss of a loved one, regardless of their age, status, or religious beliefs. To quote from the website, there are many positive aspects to this scheme, including the replacement of negative feelings of pain and loss with uplifting feelings arising from the establishment of a new life in the form of a tree. At the same time, a positive contribution is made to the environment and the community from which everyone can benefit. To my mind, this also provides a very real and tangible and continuing link between individual people and individual trees. It's about the ties that bind. Another manifestation of this need for an enduring connection might be found in those hearts and pledges of love that young people have expressed through carvings on the bark of their favourite trees. And then we can find other carvings around the city. On Bridgegate, by the river, the stonework to the upper left of the arch is of the Roman Fasces holding an axe. The Fasces is that open carrying case made of thin birch branches bound together. They symbolise the strength that can be gained from being bound together and the containment of the authority of the magisterium, the magistrates, who are appointed to serve the people. This is an enduring symbol, as we can see. It has a continuing and recurring relevance to aspects of government and authority through time. The Roman lictors are depicted on the left, carrying those fasces, as I've already described. However, if you visit the US Capitol building in Washington, D.C., you'll also see the same symbol flanking Abraham Lincoln at the entrance to the building. It's been a reference point for the American Congress since the earliest days of the Republic. And the third image, and it's where we develop the familiar term that we use, fascist, from, is the black flag of Mussolini, proudly portraying that ancient fascist symbol in the centre. So, an enduring symbol, as I say, and one that's strong enough to have been open to appropriation and reinterpretation through many centuries. On a different note, my local walks have often ended up in Grosvenor Park. I've been inspired by the colours and variety and shapes of the trees in this arboretum as spring blossomed and life went on in our pandemic times. I could find tranquility in this space, marked by the coexistence of trees from the Americas to India to Japan. and enjoyed their adaptability to life in the northwest of England. As well as a vibrant and living space today, Grosvenor Park has something of our history about it. The moment in time when the benevolence of our wealthiest citizens could be recognised through the provision of valuable and aesthetically pleasing space for the wider community. When some living symbols of an empire that stretched around the world could be settled into the heart of Chester and become an integral part of our sense of ourselves and how we seek to spend our leisure time. A contested agenda in this day and age. A final observation. My small apple tree has survived the relocation to Chester from North Wales and has produced fruit this year. It rests against the south-facing wall, and I'm hopeful that it will now thrive and grow well. I think the apple tree has been much maligned throughout our history. It's the result of a Latin pun. Malus apparently means both apple and bad. So from the fall of man in the Garden of Eden to its use for poisoning Snow White or its use by William Tell for target practice, the apple has been demonised. At the same time, its virtues are lauded. An apple a day keeps the doctor at bay. You're the apple of my eye. My own subjective view is that every garden should have one. It's a species that keeps on giving. So many flavours, so much variety, so many ways in which it helps to feed us. And yet we call it bad. Fortunately, that's our confusion. We really can't get enough of them. This is leading me towards the end of this presentation. I'd be happy to explore the nature of trees and our relationship with them in more detail, if that appeals to anyone. This would be the sort of thing I have in mind. I think this is a subject that could lend itself to a short course, maybe linked to the themes I've listed here, maybe linked to other themes that people might be more interested in. There is scope to use the lens of science and nature, where there are those big questions I posed earlier on. There are the avenues of creative writing and poetry, or of the usefulness of trees to people. There's the significance that trees have for contested political, economic and social agendas, or the imperatives linked to climate change. There is also, of course, the opportunities for themed visits or walks, or subject material for photography and art. An approach that I would be interested in would be for a programme which lasted a full year, to capture the key seasonal changes. I don't think that everyone involved would need to do the same things, but it might be worth collating the different things that had been covered. These activities might be incorporated into the planned programme of different groups, but where there's some wider appeal, then the issue of sharing and celebrating the work undertaken might be worth considering. Some activity might involve research, some might be very practical, and it would be good to look for ways in which links between different interest groups could be encouraged and developed. If anyone's interested in this, then please feel free to leave your name via the chat button or email me via the groups@chesteru3a.org.uk email address. A friend of mine, Chris Chilton, has recently completed a poetry anthology entitled How to Count Trees. What I'd like to do now is to play you a short video that includes Chris reading the title work of his anthology. There are a lot of numbers and statistics, but it always comes back to some of the ways in which trees confound our ability to measure things just by counting.
How to count trees. The number of trees on Earth before the advent of human civilization, 6 trillion. The number of trees on Earth now, 3 trillion. The population of Earth in 3000 BCE, when Stonehenge was built, 14 million. The population on Earth now, 7.7 billion. The ratio of trees to humans in 3000 BCE, 430,000 to 1. The ratio of trees to humans in 2020, 390 to 1. The diversity of living things that thrive in and among trees, currently unknown. The number of trees lost in the last 100 years alone, 750 billion. As a percentage of all the trees lost since Stonehenge was built, 25. The number of new trees planted each year, 4.5 million. The number of trees cut down every year, 15 million. The difference between the number of trees planted and those felled, 10.5 million. The number of tons of carbon dioxide per year absorbed by 10.5 million trees, 23 million. The number of raindrops that fall on the leaves of a beech tree in a summer storm, incalculable. The kilograms of CO2 a mature tree absorbs from the atmosphere each year, 22. The carbon footprint in kilograms per year of the average person in the USA, 20,000. Of the average person in the UK, 9,000. Of the average person in China, 4,500. Of the average person in Somalia, 200. The number of people forced out of the Sahel region of Africa as it becomes desert, 100 million. The woodland shades of green, red, brown and yellow through the seasons, innumerable. The parts per million of CO2 in the atmosphere in the year 1700, 275. The parts per million of CO2 in the atmosphere on February 9th, 2020, 413.7. The rise in global temperature compared to pre-industrial times, 1.1 degrees Celsius. The rise in global temperature expected by the 2030s, just 10 years from now, 1.5 degrees Celsius. The number of meters at sea levels will rise when the Greenland ice dome melts, 6. The number of meters at sea levels will rise when Antarctica's ice sheets melt, 15. The number of times sunlight, as the sun rises, dances on the leaves of a sycamore, unknowable. The displaced population of the Maldives as it's swallowed by the Indian Ocean, 500,000. The displaced people of ancient Alexandria as the Mediterranean rises a mere half metre, 8 million. The population of Bangladesh, trapped between melting glaciers and rising seas, 163 million. The pools of dappled light on the forest floor in springtime, unquantifiable. The beauty of a wooded glade in the summer luminescence of chestnut leaves, inestimable. The value of what trees know and the secrets of the forest, beyond reckoning.
And just a few final things for you to contemplate. On this slide, we have the tree which we obtain Brazil nuts from, top left. It's a towering specimen, but now very vulnerable. Then there's the American chestnut, which formed an important part of the US diet before becoming functionally extinct, as between 3 and 4 billion were lost in the first half of the 20th century. Closer to home, we lost 20 million of our elm trees in one decade and 60 million by 2010. Our current challenges include the threat to ash trees as a new disease sweeps across the country. We're clearly an accelerant of some of these seismic changes, but there are other direct causes of mortality, even if we may also be the carriers of some very real threats in some cases. On this slide, we see one of the all too familiar, shocking pictures of the evidence of global warming. The retreat of the glaciers is producing some profound changes. The reason for showing this image, though, is to show where the push for new life is coming from. The young fir trees at the bottom of the picture on the right are the heralds of a new settlement in terms of the colonisation of that land. And on this slide is a Robert Bateman painting. He's one of Canada's leading nature artists, now in his 80s but still working. This composition tells a clear story. The eagle is staring into the void, having to perch on the ground now that the forest has been lost. Prominent in the picture is the stump and buttress roots of a western red cedar. The horizontal cut marks in the stump are where the loggers wedged the platform that they needed above the buttresses to stand and saw through the giant tree. It's a scene of desolation, serves as a statement about the losses that have to be balanced against our extraordinary ability to pursue our own goals of development and growth. There's much food for thought in this image. I hope I've given you some other food for thought throughout the rest of the presentation. Thanks very much for your attention. This list of references and thanks is clearly too short, but it may help you to follow up on any of the ideas that may have been of interest to you.